don't know why we need to do that. Well, I know why we're doing it, but I don't know why your calculator makes us do it, okay? Now, from here, we are going to, again, follow these step-by-step directions. At this point, you would ignore this because we're just using the same data as before. But we are actually going to come up with two things. An equation for, let me go back for a second to this. This line that I'm sketching is called your regression line, okay? We are going to come up with an equation for this line so that it actually fits and represents our data. So instead of me just eyeballing it, we're actually going to get a solid answer. The other thing that we're going to find is, again, what's called our correlation coefficient. Okay, so let's go back to my calculator now. Again, you should have the same data in there. Do not do the backpack way. Let's just keep this data in there. But this time, you're going to go to Stat. You're going to go over to the Calc menu, and you're going to go down to Lin Reg, option number 4. Hit Enter. Enter through this list. So you get to this right here. Okay? So we have a line of best fit. Now, if it's linear, remember slope-intercept form, y equals mx plus b. They use ax instead of m, but it's the same idea. So our data that we graphed has a slope of negative 19.87 and a y-intercept of 1,425. Now, the part that I want to spend a little bit of time talking about is r. We'll talk about r squared down the road, but r. We use r as our correlation coefficient. And your correlation coefficient falls in between -1 and +1, where the closer you are to 1 or -1, the stronger your relationship. The closer you are to 0, the weaker your relationship. And then the negative sign tells you what direction it's going. Is it a negative correlation or is it a positive correlation? Okay, so let's go back to our notes here. Again, everything we just did is right here. And like I said, R is called your correlation coefficient. Okay, your correlation coefficient, again, is on a scale from -1 to 1. If the R is positive, so if it's a positive number, then that's a positive association. If it's a negative number, then that's a negative association. Again, it always falls between -1 and 1, and the closer to 1 or -1 it is, that means the stronger correlation there is. So I have a couple different examples here for you to look at. So a correlation of R equals 0. Okay, well, if the correlation is 0, that means there is no correlation. Like there is no relationship between the two variables that you might be looking at. Okay, I'm going to be taking notes on these. So on this one, there just is none. There's no correlation. For the next one, -0.3. So that would be a negative correlation because it's a negative number. And then 0.3 is closer to 0 than it is to 1. So you would call that weak, maybe even very weak. 0.5 is positive and probably call that strong. -0.7 is negative and strong. Again, 0.7 or -0.7 falls closer to -1 than it does to 0. And so again, this is another one, maybe we would call it very strong. 0.9 would be positive and strong. And then -0.99 would be negative and very strong in this case. Right? So again, by looking at one number, I might not even give you the scatter plot, but just say, hey, the correlation coefficient is 0.34. And you should be able to tell me if it's positive or negative and weak or strong just based off of that number. couple notes about correlation though. When units are changed, correlation is not. So for whatever reason, if let's say Europe does some sort of study, and Europe is in grams, kilograms, that's how they weigh things, and here in America, we do it in pounds. We could still use their data and transfer it into pounds without the correlation being affected by it. The correlation ignores the distinction between the explanatory and response variable. And the one bad thing about correlation is that it is strongly affected by outliers. Okay, so I give you an example here, and this is actually the backpack example. So here's the scatter plot that we would have made if we would have done the backpack example. And in this scatter plot, this red point out here is an outlier. So the correlation with including this point is 0.795. Still pretty strong, positive and strong. But if I take that outlier out from the data, notice how much it jumps up. It almost is a perfectly positive correlation. It jumps all the way up to 0.946. And the thing is, with the more outliers that you might have, the bigger of a jump that's going to be. And so just know that the only downside about correlation is that if there's outliers, it will greatly affect what your correlation represents. Last thing I want to do today is go into one more detail about the regression lines. So again, your regression line is just that straight line that up to this point I just have kind of sketched and eyeballed on each graph. Well, like we talked about before, your calculator can actually give you a regression line or any regression equation, and your calculator allows you to actually graph that. So again, a regression line is a straight line that describes how a response variable changes as an explanatory variable changes. The biggest thing about these regression lines is that it can help you predict a value of y for a given value of x, or even vice versa. But this only works if you have an explanatory versus response relationship. I mean, the explanatory versus response is key to this whole piece. Okay, and on your notes, it has the body weight versus the backpack weight. Again, I'm not going to go to that example. Let's just stay with the example that we've been doing. But a couple things here. What we're going to do on our calculator is actually graph. We call it a regression line. Technically, it's called the least squares regression line. And this line is what this line represents the smallest distance from each data point, as small as possible, at least. Now, as you can see from this example here, as data is more spread out, some points are further away, but this line represents the best average representation for all of these points. So what we're going to do is we're going to take the equation that we got from our calculator. Now let's go back to that. Go back to your stat menu and make sure, let's just recalculate it here for a second. Okay, so remember this is the number that we got earlier. So now, and your calculator has, see how I have an a plus bx form? It doesn't matter. You should get the same answer either way, but it's just you need to know the difference between your y-intercept and your slope. And so the equation that my calculator gave me is y equals negative 19.87, call that, so I'll round it a little bit. And that, again, was my slope, so that's my x. And then it gave me positive 1,425.027, so we'll call that 0.03. Okay, so this is what we call my regression equation. Okay, is that negative 19.87x plus 1,425.03 number. That's my regression equation. Now, what I'm going to show you how to do on your calculator is how to take that equation and graph it on your calculator. Because remember, I rounded those numbers. So if I type that into y equals, I'm going to get an estimate of what the line looks like. I'm not going to get an exact example of what the line looks like, though. Whereas there is a step-by-step process that we can follow. Again, it's written right here on your notes, but follow along as I do it here. But it will give you will allow you to graph the exact line that you need. So again, everything I'm going to do here is going to be written on your notes. But if you go to y equals, again, clear anything out if for whatever reason at this point something's there now. And go to vars, this button right here. Go to the fifth option, statistics. Hit the right button 2 times so you get to the option that says reg EQ, and then hit enter. And notice that the exact number that we found in that menu pops up right here for me, the exact number with all the decimal places and everything. Okay, just makes it easier so that we don't have to try to remember all those decimal places. And again, if we round it, well, then it's not very accurate. So once you get that equation in there, let's hit graph. And again, that gives me my line. More informally, we call it the line of best fit. That might sound familiar to you rather than the regression, but mathematically, it is called the regression line. And so your regression line is then graphed for you. Okay. The other thing that we can do with our regression line, and I don't know how this fell out of the notes, so we are going to have to add a little bit of something to that. But the point of this regression line is to make a prediction. Now again, in this example, I'm going to scroll down here where we have a little bit of space. The data that we collected was X equals the average temp in a certain month, and Y equals the gallons of gas that were consumed in that month. And again, our equation was Y equals negative 19.87x plus, I'm going to have to double check, but 1,425.03, I believe. Yes. Okay. So if we had a question that stated estimate the gas consumed if average temperature was 75 degrees. Well, we can use our equation to come up with an answer for that. Okay, again, this is the point of the equation, is we can then make predictions based off of that data. So then I would do y equals negative 19.87, and I would be plugging in 75 for x. And then I would just punch that into my calculator here, and let's see what I get. 3. I get y equals negative 65.22. Now, you look at that and you say, well, that doesn't make any sense. You can't consume negative gallons of gas. The point of me doing that is to explain that your predictions aren't always going to be accurate. And in fact, the more data you have, the better your predictions are. We only had 8 data points. Okay, so that wasn't a great amount of data. And that can be true for lots of data. If you were to track your height, okay, from the time that you were born to the time that you were 40 years old, you start tracking your height once a year. Well, people typically stop growing mid to early 20s, if not sooner. So your height, the rate at which you grow from 0 to 10, 10 to 20, 20 to 30, those are all very different numbers, so that's not a good predictor. Okay? Now, the point of this was to just show you how do I make a prediction based off of a model, and so you just plug in for x, in this case, and simplify. And I'm glad that we got an answer that doesn't make sense, just because it reinforces the point that your prediction models are limited often. Okay, if if you made a prediction of your height based off of how much you grew from age 0 to age 10, by the time you're 50, you'd be 30 feet tall because from 0 to 10, you grow a lot. And so our predictions will have ranges there that make it good or bad in this case. Okay, but that's how you make a prediction, at least. So this set of notes actually covered 5.3 to 5.7. I think I misspoke earlier. I've been kind of reorganizing a couple things here. A lot of learning targets I know, but a lot of it is just being able to break down each little step, each little different thing that you can do on your calculator. Okay.